Welcome to IndusCore Tech, where industrial engineering becomes simple. Here we break down robotics, automation, sensors, control system, and real-world industrial technology with clear visuals and practical explanations. If you want to understand the core of modern industry, you're in the right place. So here's a brief summary of what we will be covering in this video. Why OPC UA, history of OPC UA, OPC UA architecture, OPC UA security, Modbus with OPC UA, data operation, interoperability, IIoT gateway, drawbacks of OPC UA, data modeling, and a final demonstration. So let's start. So this is the automation pyramid. So in the automation pyramid is a pictorial representation of the 5 different levels of automation found in the manufacturing industry. It serves as a visual example of how technology is being integrated into the industry today. So let's break it down, okay? So first thing first, we have the field level. On the very bottom of the automation pyramid, we have the field level, which consists of a wide variety of sensors, actuators, and other devices found on the production floor or in the field. These devices do the monitoring of physical work. Some examples of these devices are electric motors, proximity switches, photoelectric switches, as well as hydraulic and pneumatic actuators. Then we have the control level. Without some sort of controller, the field level device cannot do very much. You must have some sort of computer to control these devices. That is where the programmable logical controller PLC or the program automation controller PAC come into play. The PLCs and PAC are both industrial computers constructed and adapted to control all types of machinery within harsh environments like manufacturing facilities. So these types of controllers take information from all the field devices, sensors and switches to make decisions on which outputs to turn on or off to complete the programmed task. Then we have the supervision level. So this next level is where you find supervisory control and data acquisition, SCADA systems, as well as human-machine interfaces, HMI. So a SCADA system is a collection of software and hardware components that allows the supervision and control of plants, both locally and remotely. So this system is used to examine, collect, and process data in real time. Also within the SCADA software, there is the ability to log data for historical purposes. The data from the field devices are routed from the PLC or PAC to the SCADA computers, where the software interprets and displays the data to the HMI screens. The HMI screens are where the operation analyzes and directs the system's events. Then we have the management level. The management level can also be referred to as the planning level. At this level, a management execution system is utilized to monitor the entire information of a product from raw materials to finished goods by tracking and documenting through the various stages of the product's manufacturing process. So the management can be a better understanding of the current condition on the plant floor so that the right action are made to improve production output. And finally, we have the ERP, so the management system is called the Enterprise Resource Planning System, which is mainly used for a company's top managers to monitor all the departments of the business from sales to purchases, manufacturing, finance and payroll, and so on. So this suite of applications shed light on what is truly going on through the whole company to better promote efficiency, transparency, and where improvement need to be made. So we have this pyramid, and the question we are asking is, how do we successfully collect this information? How do we get the data stream flowing from the bottom up? Is there a technology that allows us to do this without changing protocols and adapting our information to each type of network? And most importantly, is this technology secure? So a simple summary of the OPC UA story. At 1996, so we have the birth of the OPC. The creation of the OPC Foundation highly dependent on Windows. It was insecure and difficult to configure under COM-DECOM. So what is this technology? To explain it briefly, it's the ability to run a program or software on a computer other than your own, but located on the same network as you. Then we have the arrival of the OPC UA on IFID architecture at 2006. So here we have a technology that is more adaptable to any OS operating system, so it can work in Android, Windows, Linux, etc. It was secure and the information can be complex and structured. And from 2015 to now, it has become an official standard used and supported by the majority of industry components. So we have a computer and a PLC. Generally, in this type of architecture, the client is always on the computer side and the server is on the machine side. We will connect them with a cable, an Ethernet cable or whatever. The PC screen will serve as our control and monitoring screen. We will now install an OPC UA block on both sides. An OPC UA client supported by the application on the monitoring side and an OPC UA server block on the PLC side, which will have access to the PLC internal memory. For communication, the client always initiates the process. It requests information and the server responds. And there you have it, your OPC UA server client. The advantage of using OPC UA, although it's not mandatory, is the security aspect. This is achieved through the installation of certificates that contains a set of security rules. I'll go into more details about this in another video, but for now, what is a certificate? And what does this certificate contain? It typically includes the name of the client or server, the public key that is used to encrypt information that only the owner of the private key is authorized to receive, the issuer's identity. It's the certificate identity or authority, which can be a paid service or a self-signed certificate. I will show you how to create a self-signed certificate for free in one of my upcoming videos. The certificate also includes the creation and validity dates and also the authorized users. It's a set of rules established to ensure secure communication, etc. Thus, the certificate provides authentication, verifying the identity of the server or client. It also specifies the type of encryption used during data exchange and ensures the integrity of the information, guaranteeing that it hasn't been altered. Connecting a server to a client with a different certificate, or connecting a server to a client without a certificate, or a client to a server without a certificate, will result in a communication failure. In this brief comparison with the Modbus protocol, you can see that this protocol only allows for the transmission of digestible and simple information. For example, the temperature and pressure in a tank, which are tangible and measurable data. With OPC UA, we can send much more information, as you can see here. You have the value, timestamp, unit, quality, description, min-max limits. We can thus describe our tank, define its location, record the history, define minimum and maximum value, and much more. And the box will protect our data because it's locked. In the client-server structure we presented earlier, I talked about sending requests and responses. When the client requests the information, it's in read mode. When the client sends a new variable to the server, a sort of command, it's a write operation. When the client wants to obtain information frequently, it's called a subscriber. and when it wants the server to send it information as soon as its state or data change, it's called the publisher. You will find here what I just said. Read. The client requests a value only once. As an example, what is the tank level now? Write. The client changes the value of a variable. Example, set the valve to the open position. Now subscribe. The client tells the server, automatically notify me when the values change. Example, I subscribe to tank level, I receive notification if the level changes. Publisher, the server sends notification to clients that has subscribed. I made an analogy with the time factor to help you understand better. So read, it's like checking the time. Write, it's setting the time. Subscribe, setting an alarm. And publishing, the alarm sounds when something happens. To discuss interoperability, I've prepared these connection diagrams to demonstrate the power of OPC UA. First, you have an OPC UA client supported by AVEVA supervisory software, which is, by the way, I believe was acquired by Schneider Electric. We can connect a Siemens PLC to it, which has an OPC UA server block installed. But that's not all. We can also connect it to a Schneider PLC like Modicon, which will communicate with its OPC UA server block, and also to our Rockwell Automation PLC with its OPC UA server. OPC UA can also be used as a protocol for embedded system, as in this example with a NodeIds server installed on a Raspberry Pi, which will be used to capture measurements in its environment, as an example. It can also be used with a NodeIds server on a computer, a Python server on a computer, or even with a ready-made solution where you only need to purchase the license like Prosys, OPC UA server. The OPC UA client can communicate with different machines as long as an OPC UA server block is installed. Similarly, servers can communicate with different OPC UA clients as long as the block is installed on the software. This could be a NodeIds OPC UA client, a Python OPC UA client, or ready-made installation like UA Expert. We sometimes encounter this type of architecture where an intermediary is needed. In this case, the server installed on our PLC will first communicate with the Python OPC UA client and then send the received data through the Python OPC UA server to the AVEVA supervisory software, which has the OPC UA client block installed. A client always communicates with a server and the server always with a client. There is no server-to-server or client-to-client communication. For my demonstration, I will connect my UA Expert client to a Prosys OPC UA server. But before that, I will talk about the IIoT gateway. They act as OPC UA servers and are used to enable communication between older machines that cannot support the OPC UA model, and it allows the data to be converted or encapsulated in a frame that respects the OPC UA model and will thus allow the exchange of data with OPC UA clients. So now we will talk about drawbacks of OPC UA. So it's often said that OPC UA is an open source model, and that's true, of course. However, if you want to use the OPC UA logo or label, it's essential to send your code to a center accredited by the Foundation for Testing and Validation, especially the security aspects. And of course, this service isn't free. The fees can reach several thousand euros depending on the processing of your code. On average, it takes 5 to 10 days for the client and 3 to 7 days for the server. I will include a link to the OPC UA Foundation website in the video for those who want to learn more, as well as a link to the Unaffed Automation website where they offer a better and more comprehensive explanation of the model. So without the OPC UA label, you can, for example, create your own OPC UA model, your own server client, and use it within the company or factory. However, you cannot sell a machine with OPC UA blocks or even software without the approval of an authorized testing center for security reasons, and that makes sense. Second drawbacks is the imperfect interoperability between manufacturers. Example, a Schneider PLC needs to communicate via OPC UA with a Siemens PLC. The result doesn't work or it crashes. If you call Schneider, they will tell you it's not us. We've structurally adhered to the OPC UA model structure. We've tested different types of our components and they communicate with each other. You need to contact Siemens. If you call Siemens, the same thing happens. They will tell you they followed the model. The best solution is to replace the Schneider component with a Siemens component and they will guarantee you proper operation. And the cause are because each manufacturer implements OPC UA in its own way. Some implement OPC UA minimally, just the server, few tabs, little security. OPC UA profiles are not always the same between manufacturers. Hey, hello guys, just don't forget to subscribe to the channel, share it with your friends, put in likes and comments below the video. Thank you. The third one is manufacturer lock-in. OPC UA is often added as a secondary suboptimal features. Manufacturers still favor their priority protocols. Profinet is set for Siemens and Ethernet IP for Rockwell. Complexity. OPC UA is rich, structured, secure, modeled. More complex to configure, more resource intensive than Modbus or S7 requires a dedicated network architecture, certificates, user permissions, variable security support. Some older equipment does not implement the X509 certificates, modern encryption methods, and user management. OPC UA is more than just a protocol, it's a model. It can transmit complex information, organize it hierarchically, and keep it secure. It's a tree structure, so let's start by defining the different elements and some of the names it contains to understand it better. Namespace, variable, URI, URN, URL, NodeIds, method, and so what's the difference between all this name? URI, Uniform Resource Identifier. It's a name or address that uniquely identifies a resource on the internet or within a system. So the URL is a Uniform Resource Locator. It's a type of URI that provides the address to locate a resource on the network. As shown in this example, OCP, point, TCP, colon, etc. Then there is the URN, Uniform Resource Name. It's a type of URI that gives a unique name to a resource without indicating where it's located. As shown in this example, URN process colon trunk system. Why trunk system? Because it's our example. I'd like to introduce you to Mr. Smith. Here the last name represents the namespace URI. He was registered in the New York City Registrar. The clerk working there filed his record in Section 5, Jar 12. It's as if our server decides where to file his birth certificate. His first name is John. Here the first name represents the NodeIds. Mr. Smith has 3 children, so they automatically inherit the name Smith. They all share the same namespace. The first is William, the second Jessica, and the last Martha. The first 2 are performing an action called a method. In the OPC UA model, they are both awake, while the youngest is in off mode. Each of Mr. Smith's 3 children has a unique character trait or property. The first is brave, the second is smart, and the last one is shy. Each of Mr. Smith's children has a different age and unlike properties. Their traits are variable as they change over time. All of these represent a set of nodes and links that, through interconnection, constitute an OPC UA tree. Let's now try to translate this and project it into the industrial world. We now have our tank defined by a unique URI, which is URI tank system. The server has assigned us our namespace index, number 7. It can be any number, but the number O is assigned because it's the root directory. The node ID here is represented by the namespace and the index. The namespace doesn't change because it's the same parts that are in our tank folder, and the unique serial number is assigned to each one. It can be an integer, a name, or something else entirely. Here is the node ID of each of the valves that control the tank. The first two valves are open and the last one is closed. In our example, the unit liters per second is represented by the property, and finally the variable represents the flow rate. So welcome to the OPC UA simulation server, Prosys. So here the server status is running, and this is our URL that will help us to connect to our client. So here let's try to create our tank folder. So here I just created the tank system, so you have just to create it here as this. So I will choose it, and here we'll call it tank. So this is my tank folder that will contain my valves. So now we will create my variable. So I will create 3 valves. So here it will be valve 1, valve 2, and valve 3. Okay, so for each of the valves I will create a method and a property. So the method, it will be on-off signal. So if the valve is working or not working, it's stopped, and the property will define our unit. So here I will let it as shown this, but here I will name it so I will name the method, and it will boolean true or false. And here we create our virtual string. Yeah, I choose the string because it's the data type. What kind of data will represent the name, the unit? It will be the liter per second. So I will just write it and show it in the screen. Okay. So I will unit string unit string. So now that I created this, let's make our modification. And first thing first, I will give to my valve flow rate. So the value. So for the first time, I will give like 15. The second one I will give 12, and the last one, okay, 25. Okay, so let's switch to the UA Expert client. So here it's our unified automation UA expert client. So it will help us to connect to our server. So first thing first, you need to come here, custom discovery. So to add the server, the OPC server. So I will just paste it here. Okay, here I'm connected to my server, simulation server, and I will choose the none one. Yes, because OPC will permit you to connect and securize your data by different type of cryptography. So for this example, we'll just do it without any security. I will show you next time how to create this certificate and how to cipher your communication. So here I will connect to my server, and here I will find my folder. You will see that our root has a namespace index O. It's always the O for the root, so you cannot assign this number to any other folder that you will create. So this is number 7 for our tank, and here you will find the valves, the folder that will contain our valves, valve 1, valve 2, valve 3, and their communication, their information. So here we try to So here for the unit I will string, and here, so here as shown below will tell you that my valve 1 has a full weight of 15 liters per second and it's open. And for example, we'll take the second one, and here I will let it false, so it's closed, and of course the unit will not change. And I will do the same thing with the last one. I will open it. The unit will be the liter per second, but what I will do here, I will change the information. So from my client, I will tell my server, please, I want more flow rate in my tank, inside my tank, so they will change it here. So here when I come to object, yeah, as you can see, you will find this information below. And for the others, you can find that for the method, for the valve 2, the valve is closed. It's false. So this is all for me. Thank you for following me. Please don't forget to subscribe and to comment below the video. Wassalamu alaikum.